Here we are in our final series on loops. We're going to look at the syntax and program flow of for loops. One of my favorite cartoons, right? Get it right on the board 500 times. I will not throw paper airplanes in class. Now this is the C example. Basically, he just simply wrote a for loop, right? That counts from 1 to 500 and prints out the message 500 times. Teacher was not impressed, right? A little bit of programming humor there. Right. So the for syntax takes a little more getting used to than the while and the do while syntax. The keyword is for, and inside parentheses, we have an initialization action. This is where we're usually going to set our variables to their initial values. We have a Boolean expression, and then we increment our controlling variables, increment, decrement, whichever way we're going, up or down. Out here is a third action. And then we have statements within the body of the loop, right? So the way this executes is for this initialization action. So action or actions, because you can have multiple statements here. These happen once and only once. That's why they're called initialization, right? When the for loop starts, it will execute the code in this initialization action. So look at the flow chart here where it says init, this is where it initializes everything, right? Then it goes on to perform the test condition. So this Boolean expression is the test condition. Works just like every other loop. As long as this test condition is true, we're going to go into the body of the loop, execute that code, and then we execute. When we get to the end of the loop, it comes back up and executes whatever statements are out here in this increment section, right? So the syntax is just a little bit different and getting used to the order that this executes in. But again, the test is always evaluated before executing any statements in the body of the loop, just like the while loop. Again, what I just said on the previous slide, this one should help you remember. Initialization statements are executed once and only once. The Boolean expression is evaluated. If true, the code block, if statements inside the loop body executes, we're going to perform any update action. So instead of calling that increment here, if we call that an update action, that's usually an increment. Those will be performed. And right, then it comes back, evaluates the Boolean expression. If that's true, it goes back and keeps performing these steps over and over again. Right. So let's take a look at a for loop that looks very much like our while loop. And let's pop up Visual Studio here. Right. If we run this code, generate our output. Again, we're going to generate the outputs 0, 1, and 2. But our syntax instead of the while loop is going to be the for loop. So here we've declared a variable of int type named count. Here's our initialization action. So inside the parentheses here, this for loop, we've initialized count to 0. So this will happen once and only once. Right. The next thing that happens is this test condition is evaluated. So count less than 3. Well, count 0. So is it less than 3? Yes, it is. Because it is, it's going to go in here and execute this statement, our single statement inside the body of the loop, which says to print out the value of the count. We get to the end of the loop. This goes back and then executes this statement. So this increment statement here, whatever update action we're performing, right? You don't have to just add by 1, subtract by 1. You might be multiplying by 2. You might be dividing by 1/3. It all depends on your programming logic, right? What you're trying to do. But we're now going to add 1 to count. So we came here right after the end of the loop. We come back now and we do this. We add 1 to count. Count was 0. Count becomes 1. The next thing that happens is the test condition is evaluated. Count has a value of 1. Is 1 less than 3? Yes, it is. Because this is true, we execute the statement or statements inside the body of the loop. So we're going to print out the value of count. In this case, it's 1. We get to the end of the loop and we say, oh, well, we need to go back and perform these actions. So this action says to add 1 to count. Counts 1, we add 1 to it, it becomes 2. Next thing you do is you evaluate the test condition. Is count, which has a value of 2, less than 3? Yes, it is. This is true. Execute statement inside the body of the loop, right? Print out the value of count. Get to the end of the loop, we loop back here and we perform these update or increment actions. In this case, count was 2, we add 1 to it, it becomes 3. And then we go perform the test condition. Is 3 less than 3? No, it's not. So we then fall out of the loop and we would go execute the statement immediately following the end of the loop, right, which in this case is return 0. Right. Now here's where you're going to see these increment and decrement operators commonly used. There's nothing in the code that really that is dependent on how this expression evaluates. Remember, postfix says to go ahead and evaluate the value of count and then add 1 to it. Well, there's nothing depending on it. If our only operation is we're just interested in adding 1 to count, we could just as easily do this, because we're not doing anything with that, how that expression evaluates. We're not doing anything with that value of count, right, other than simply having the side effect of adding 1 to memory. So you can do that. It's the same. Or you can say count equals count plus 1, or here's where it's handy to use that count plus equal 1, which is the same as count equals count plus 1. So all of those methods will actually then cause our loop to execute in the same manner. It will not change the behavior. All right, if we run this again with count plus equal 1, show the output, we get 0, 1, and 2. Right. All right, so it's getting used to that for loop syntax. Right. And so here, let's look at a different example where we're not incrementing count by 1. Right. So we've got this variable count. We declared out here. Right. In here, we're going to initialize count equals 1. As long as it's less than 5, we're going to print out the value of count. And then instead of incrementing, we're just going to multiply it by 2. Let's go ahead and make that change. Like this slide shows the output, the next slide, but let's just go ahead. Say count equals 1, count less than 5, and count times equal 2. That's count equals count times 2. If we run this, what do you think the output will be? All right. Well, the first time the output of count is 1 because we initialize count to 1. So remember, this happens once and only once as our program executes. And then we can perform the test condition. Counts 1 is 1 less than 5. That's true. So we're going to go ahead and print it out. That's why we saw the 1 printed out here on the screen. And then when we get to the end of the body of the loop, we come back and we perform this update. And so this says to take what's in count, multiply it by 2. So 1 times 2 becomes 2. Right? We change what's stored in count. Next thing we do is we perform the test condition. We say, well, is 2 less than 5? Yes, it is. So let's print out the value of count. And that's why we see we get a 2 in the output. Again, we get to the end of the body of the loop. We come back up then here and we execute these statements, or the program does. I say we. And so count is 2. We're going to multiply it by 2, which makes it 4. We then evaluate the test condition. Is the test condition true? Is 4 less than 5? Yes, it is. So we're going to print out the value of 4, which we saw in our output here. Right, and then here we're going to get to the end of our body of our loop. We're going to come back up. Now remember, this is equal to 4. 4 times 2 is 8. So count's going to be 8. We're going to perform the test. Is 8 going to be less than 5? No, it's not. So this is false. So we go execute the next statement beyond the body of our loop. In this case would be return 0 to return from main. All right, so that's just an example that you can work through so you can predict what the output will be. Like I said, just something to show you that you don't always have to increment or decrement count. Another option as well is that instead of declaring count out here, we could have declared it in here. Right. So here we're declaring count, we're initializing it to 1. we're still going to have the same program flow. This is going to happen once and only once, right? We perform the test condition. We should still get the same output, the 1, 2, and 4. It's running. So we still get the same output, 1, 2, and 4. The only difference is by declaring the variable count in here in the for loop. If we were to try and access count out here, I'm going to say count. Oh, let's go ahead and see out. End of loop. Let's print out the value of count. Right. We should get a compilation error. There were build errors. Do we want to continue? No. No operator matches these operands. Interesting. I was hoping it told us that count was not declared in that scope. Oh, it thinks, okay. So here is a conflict with using namespace standard. Don't know if you can see it on the screen. It's coming up and telling me that in the template class, there's already an iterator that's been declared standard with a function of count, standard count. And so it's actually thinking here when I'm using count that we're using something from that library, right? That function template count, but we're not. The reason is simply because when you declare count inside here, its scope, the time you can access it, the time it exists in our program is from the time we declare it until the time we end a block of code. And these curly brackets indicate a block of code. Even though we didn't declare it inside these curly brackets, because we declare it here, as soon as the for loop is done, count no longer exists. Right? Otherwise, if we declare it out here, now actually, let's just call this C instead of count so we don't have that conflict with how about that template. Still complaining about it doesn't know what to do with that. Oh. Actually, I don't want that there. I still want to declare it inside the loop. All right, now because it's not got a conflict with something in the standard namespace, it's telling me that identifier C is undefined. I haven't even tried to build it yet. It's already telling me this before I try to build, so I should pay attention to that. But I said if I missed that and we tried to build, we would get these build errors, which are the same as what it was telling us before. Right, identifier C is undefined. And you can see where this is where the error is here. And that's because C only exists as long as it's running the code inside the body of the loop. Right. Otherwise, now if we set int C, and here we went back to saying C equals 1, because we declare C within the main function, so in between these curly braces here in main, then anywhere in main after we declare C, we can use it. Here we set it equal to 1. Don't know why that's being so slow. Oh. I'm not quite sure. Maybe I still had it running from before. I'm not quite sure why that kept doing that because they didn't change the code. I simply shut this down and rebuilt. All right, you can see we still get the 1, 2, and 4. And now we're printing out at the end of the loop. Oh, well, I said count. That's actually our variable C. We're printing out C. And my message didn't match. Now our message will match, but we'll see the same thing, right? That C is actually equal to 8 at that point. All right, so just a little bit about that. Like I said, common mistake for newer programmers. Not that it's a mistake to declare this here, right? But a common mistake is declaring that there, and then you will try to use it later in your program, and it should be giving you some error messages about that. All right. Getting a little more complex, we can nest loops, right? You can put loops inside loops. You can put while loops inside for loops inside while loops, right? Any combination, while loops inside of do while loops. Right? The reason for doing something like that likely become more clear when we get to data structures called arrays. And we have a two-dimensional array, and we need to go through the rows and columns of that particular array. So we will revisit that at this point. This is just to make you aware of you can put loops inside loops. And we can work with this then. If you look at it, we can start answering the questions about how many times will the loops run. These are good questions to understand or check your understanding. Right, so we've declared two variables, I and j. We're going to output a message program starts. And here in this for loop, we initialize I, we set I equal to 0. And then we check the test condition I less than 2. And we're going to add 1 to I every time this test condition is true and the code inside the body of the loop executes, we'll add 1 to I. So this test, I less than 2, will be true when I is equal to 0 and I is equal to 1. Right? When I is equal to 2, this test condition will fail. This is the start of our loop. Here's the end of the loop. So when this test condition fails, the program flow of execution will go down and print out, we'll execute the cout statement to print out program end. Right. So the answer to this, how many times does the outer I for loop run? It will run twice, when I is equal to 0, when I is equal to 1. How many times does the inner loop j run? So here's the j loop, which is inside the for loop. It's another for loop as well. Right. So when j is equal to 0, we're going to set it equal to 0 here. That'll happen once when this executes. As long as j is less than 3, this test condition will be true. So this test condition will be true when j is 0, 1, and 2. This will be true 3 times, right? And the way this works is we set j equal to 0. We test the 0 less than 3. Yes, it is. We go ahead and print out this information inside the j loop, what the values of I and j are. Here's the end of this for loop. At the end of the for loop, we go evaluate then this increment step here. So plus j, we add 1 to j. This test will be performed. We'll then keep executing this loop over and over until this test condition, j less than 3, is false. So j will be true when j is equal to 0, j is equal to 1, j is equal to 2. When this becomes false, when j is equal to 3, well, the next line of code that's executed is the statement immediately following the end of this for loop. The end of this for loop is signified by this right curly bracket. So we'll output a message j loop done. And then the next line of code here is this right curly bracket. Well, that's the end of the for loop. I'll call that the I for loop. Right? And so when that's finished, it's going to come back up. This starts out with I equal to 0, right? It checks a 0 less than 2 is true, right? We said when that's true, this code will execute. Right? It's going to come back up here. I was 0. We're going to add 1 to it. I is going to become 1. 1 will be less than 2. This condition is true, so we execute the code inside the body of the loop. That means this loop is going to execute again. So we said this loop is true, or this test condition is true whenever j is 0, 1, and 2. We said that will be true 3 times. We know this executes 3 times, however many times this outer loop executes. This outer loop executes twice when I is equal to 1, or I is equal to 0 and I is equal to 1. So these statements inside the J loop execute a total of 6 times, right? J less than 3 is true 3 times, I less than 2 is true twice, 2 times 3 is 6. Right? And so that gives you some idea, right? Go ahead and type this one in, run it, use the debugger to step through it. It gives you an idea of how a loop within a loop works. So we'll be using these when we start getting to 2-dimensional arrays or any other sort of data structures that have a second dimension. Right. Next slide shows you the output, right, of what the values of I and J are, to give you an idea of how to walk through that. We talked about for loops, while loops, do while loops. Remember, for and while loops both evaluate the test condition before executing statements in the body of the loop. So in general, right, a for loop is preferred for a counter-based loop. A counter-based loop means we know how many times that loop should execute, right? And again, when we get to data structures such as arrays and other data structures, where a data structure will have more than one value stored in it, and we'll want to go through all the values stored in the data structure, then we'll typically know the length of the data structure, and we'll know how many times we need to go through that data structure. We typically write a for loop to do that. Right. A while loop is preferred for what we call sentinel-based loops. There's some sort of code that's going to check for some input, some sort of value, a sentinel value that indicates when that test condition will be false. An example is, suppose you're playing a game. You get to the end of your game and the question pops up and says, do you want to play another game? If you say yes, it restarts execution of a new game. If you say no, a lot of times your program ends, right? Then you would use a while loop for something like that, because you don't know how many times a user is going to say yes I want to play another game. And so that's an indication of a sentinel, right? That's something that we don't know exactly how many times the user is going to say yes. It's that user input that will control how many times that loop test condition is true for, do you want to play another game? Right. Either kind of loop, so you can always write a while loop, you can convert it to a for, and you can always convert a for to a while loop. So a lot of times people get more comfortable with one over the other, and especially newer programmers tend to pick one over the other and stick with it. For some of our homework, you will be forced to use both so that you get an idea of how to use both. Right, that's it for loops. In our next video segment, we'll talk about break and continue statements.